Thank you and welcome to Universe 2022. And You're in the acceleration of your data privacy and protection initiatives. My name is Rainer Kappenberger. I'm the Director of Product Management for Voltage Data Privacy and Protection. And we've all seen a lot of privacy coming around over the last couple of years globally. It all originally started with GDPR out of Europe, and in total now over 137 countries, that's almost 71%, have privacy regulations already. Another 9% have draft legislation in progress, according to the UN Conference on Trade and Development. GDPR for this is very much a blueprint for privacy law. It's a transforming regulation that establishes data privacy as a human right. Most other regulations emulate the GDPR, some with great similarity, such as California Consumer Privacy Act. And it's really going in the US moving forward as well. Because taking a look at the state of data privacy law in the US, it used to be far behind, but now we've got many states that already have enacted, signed, and passed regulations that are in committees or being introduced as such. The majority of the states in the US are moving in the same direction. Again, the California Privacy Act is very much in this regard similar to what the GDPR has been doing for Europe. But there is also the assumption that with those privacy regulations, the fines are going to be far away. Well, looking from the past when the US introduced the HIPAA regulation, it took almost 10 years until the first fines were issued. With GDPR, it has proven completely different. There is already over 900 GDPR fines issued across the European area since May of 2018. And the fines, because GDPR defines the fines pretty high, they are in effect growing every time with the data breaches. The latest one that we've seen from Amazon, which almost had 877 million US dollars. But they're not the only ones being fined. It hits everyone. And alone in 2021, in the Q3, nearly $1 billion in fines have been issued in Europe. That's 20 times the total for Q1 and Q2 of the same year combined. So we can see and expect this trend to continue over the coming years. But what does that mean for your organization? The first part that you have to ask yourself, where is my data? And data can be anywhere. It can be in your file shares, it can be in databases, it can be in clouds, and people are just keeping copies of data everywhere. So you need to have a good understanding of what kind of data do you have in your environment, which leads to the part what you really need to do is have a comprehensive data discovery strategy. And as I said before, data is everywhere: endpoints, application, databases, files on file shares or on the endpoints. You really need to make a good inventory of what you have and how you actually are using it. This requires a risk analysis and assessment of the data. It requires you to do a data classification and analytics behind the data to really understand what's the data is and what is its business purpose in your organization. You also need a proper data access governance strategy. Who has access to what kind of data and for what business purpose? Data anonymization and cleanup are necessary tools in that equation as well. You need to protect your data in use and enable secure collaboration between people. And data discovery requires a full analysis of the actual content. Only then can you start looking at data minimization and an assessment of your privacy readiness. But it also covers areas like test data management, data privacy readiness, application retirement in your organization. When you do those steps properly, then you can actually move to protect the real important information in your organization and perform proper data lifecycle management on these data elements. Let's have a quick look at the voltage data discovery solutions and how they work in the real world.
So we got a mixture of data. It could have been metadata or content index. It doesn't really matter for this use case. When we're checking for duplicates, this is duplicates based on the hash, and the hash is counted as metadata. So it doesn't really matter what level of analysis. And I've got a number of different repositories here. I've got some stuff in Teams. I've got Content Manager, of course. This is what I'm going to compare against. Exchange, file system, it could have been emailed. So these could have been, if these are emailed and sitting in people's email folders, we can check for those as well. SharePoint or file systems. And these 46 items that sits in Content Manager, we're going to see if there's any copies of any of these items in any of these other locations. How do we do that? We can go straight to the Manage section. So we would create a new workspace based on a template. So we would call it something like duplicate corporate records or something like that. And we'd use the data cleanup template, and that gives us our categories for redundant, obsolete, and trivial. Okay, so I would just create a workspace based on that template. You can see I've created one already here today, so let's go in and then have a quick look. You can see I've already added some data sources in here just in preparation for the demonstration. I'll show you what I created. And the most important thing that we do here is we create, a couple of different locations. So these are inactive, so don't worry about these too much. But we need to create a data source per repository. You can't have them all existing in one data source because that's how we do the comparisons at a data source level. So we need a data source per repository, so Content Manager, Exchange, File System, and SharePoint. Okay, so you can see in our timeline, we've got some quite old data in there, but really I'm not interested in the age of the data. All I'm interested in doing here is looking for the duplicates. So across all I've got Word, Excel, PDFs, emails, Excel files. I've got a mixture of data, so it doesn't really matter what type of data in there. All I'm doing is looking for duplicates of those corporate records, so any of the ones that exist in Content Manager across other repositories. How do we do that? We go to the workbooks and we'll create a new workbook, call it duplicate corporate records. I'll give it a category redundant. That means it goes into this category over here on the left hand side. And we use the fourth option on here called task. Hit select to configure the task. So this, I'm not really wanting to do a deduplication inside those inside file systems. But what I do want to do is because where there is an official record, see if there's copies elsewhere. So I choose just the first option here. Secondly, I need to, when I'm comparing the sets, I need to select the data source, which is our official records. So in my environment, my content manager is my official records. That's what's working. So this is where my official information is, and I'm looking for copies in file systems, Exchange, and SharePoint. And that's about it. There's very little else to configure. So let's hit finish and then hit create. And that kicks off the process. And you can see the status is pending here and it's going through identifying the duplicates. It's a relatively small data set, so I'm expecting the results to come back very quickly. In fact, they're back here straight away. So that did it really quickly. So I'll just refresh the page and you can see the status bar will show me that it's completed. All right, so it's found 2 duplicate corporate records in the system. Okay, let's go and have a look and see what these duplicate corporate records are. So we've got 2 Word documents. Here, these 2 Word documents. You can review each of these and see the content of them here. Let's open up the scroller on the right-hand side and look at the metadata. You can see where they are. So the duplicates in Content Manager. So, well, the official copy is in Content Manager, and our duplicates sit in here. And where is our duplicate? This one's in SharePoint. So this is the finance report that was from September that was in SharePoint, and it's sitting in. If you can look at, see, it's actually sitting in somebody's OneDrive folder. Again, this one's sitting in SharePoint as well. So we've identified the two locations of where that data is. Now, the one thing, important thing to do is say, is this still useful? So we can check the dates. This is a relatively new document, so we might want to leave that in place. Is it still important to the business? So we can use some of the metadata and the information to find out, and the location of the information to find out, is this information really needed? If the information is old, it's sitting in a SharePoint site or a file system that is, and it hasn't been touched for some time, you're thinking, this really needs to be cleaned up. These are duplicate corporate records that should be removed. If they are duplicate corporate records that should be removed, we can simply go to the Activity tab, go back on our workbooks, go back to the Activity tab, and all we have to do is hit the Delete option. This will check if this has a whole operation on it, then it'll keep those duplicate copies. I would just have to select the reviewer. Who should we set up here? Let's select Gwen as my reviewer. And this will actually submit this for approval. Gwen would say, yeah, we don't need those copies anymore. So perhaps like the owner of the SharePoint site, then we would send them, say, look, we've identified these as duplicate records. You need to review these. And if you accept that you're not using this information in this location anymore, then after they've reviewed and accepted that, these will be deleted from the system. Okay, so once these have been executed, there's a report produced. So we can report of the information of these duplicate records. So it's the same report that we have. So two ones that we had identified. And there's also an audit of those activities. So who created the workspace, who identified them as duplicates, who submitted the action, and who reviewed the action will all be included in this audit. Okay, so this is the way we identify duplicate records. We're cleaning out copies of duplicate records that exist inside any of our unstructured data sources. Okay, so we saw that previously we just using our existing analysis that we connected through and we did analyze, and we add in extra value by making sure that the only copies of our official records are kept inside our chosen archive repository. Okay, thanks very much. Bye for now.
The other aspect that people frequently overlook, when you have a proper data discovery process in place and classify your data, you can actually gain a lot more insight than just what kind of data do you have and what it is being used for. The real benefit is when you do this, you can actually start looking at what is my financial exposure in case there would be a data breach. This is a critical aspect that successful companies have taken in the past already. And the way we're supporting that is taking the part and introducing our data loss risk calculator. This calculator enables companies to better understand the operational cybersecurity risk a company actually does have. Using the data that is collected from our discovery products, we can identify the different fields inside a database or inside of documents, and we can then model the financial exposure in case the data is leaked. This calculator is based on a combination of the IRIS and Ponemon studies, so it's actually based on industry accepted calculators and not a micro focus made up number. What it also shows here is risk is not a fixed number. It is a kind of a bell curve. And in this example here, Ponemon would say the average for this kind of data analyzed here would result in $14 million of fines. And not only the fines is calculated in here, but it also takes the other aspects like in the US credit card monitoring, etc., into account, or lost revenue for the company. The average based on iris would be about 17, but the high point probably about $36 million. So you can see a range of where the potential impact of a breach could lie. So how do we translate data volume into monetary risk? Let's assume we have 100,000 rows of customer PII. That could be a loss of around $800,000, but there's also a 10% chance it cost over $21 million. The average that we would expect is like $3 million. Why is this part important? Because each breach is treated differently by the regulators as well. So it's not a generic sum that says $100 or $50, $200 per record breached. There are multiple factors going into the equation. So we accommodate that by showing you this bell curve that gives you a much cleaner insight into what is the potential risk that the company is facing. But at this point, it's not all the data has the same risk. When you look at the parts, different elements have different costs associated with it. There is a difference between customer PII and employee PII. In case of employee data being breached, the fines are typically, or the cost to the organization are less than customer data. IP or anonymized customer data also have different risk attributes. All of this is taken into account in our calculator. So now that you actually understand the risk and the exposure from the organization to a potential data breach, what can you do to minimize those risks? One thoughtful part is actually think about data minimization. So here's an example from the Americas. So if you have kids and they want to play sports at school, you typically have to fill out a medical clearance form. And often this form is full of medical history. There's all kinds of data that are covered by HIPAA regulation. So what the American Academy of Pediatrics has done, they removed a lot of these elements so that schools do no longer collect this sensitive HIPAA information. All the school really wanted to know at the end of the day is it safe for the student to participate? And this is what the new form does by minimizing the exposure of the school to HIPAA data. So what can you do to minimize your data? There are different challenges in different areas. Number one is the unbridled growth of unstructured data. We all see the spread and the effects every day. We have copies of data floating around in multiple SharePoint sites. People keep another copy on their laptop, and so forth. But it's also the migration and shift to cloud applications. The desire is always to keep the data at hand in the particular areas. We also see more and more applications coming along and creating even more data, and mergers acquisition, the traditional part, is also playing a part. Analytics is just another way of keeping another copy of the same data for multiple purposes. But this all conflicts with the regulatory and privacy complexity because now privacy being a human right, the way that GDPR defines it, creates really the need to look deeper into creating less data copies. So what are the ways you can evolve your data security posture? Number one, understand the value of data. And you can do that through data discovery and classification. Understand really what kind of data, what business purpose behind the data is, and where it's being kept. But then protect sensitive data. And with protecting sensitive data, this can be done in different shape and forms. You can use secure data, format preserving, encryption, tokenization, hashing to remove or obfuscate the actual identity behind the data, but business purposes and collaboration can still operate on those. Or, for example, in the case of analytics, you can still analyze the information to drive benefit without the exposure of live data. But one of the key aspects is really reduce redundant, obsolete, and trivial data. We all have multiple copies. Try to look at this is an older version of the same file. Do we really need the 25 older copies of those files because they're just another 25 attack vectors? And you can do this through a defensible disposition of data. And as we grow the applications in our companies, we also have the typical situation that applications get retired. And what are we doing about the old data in those applications? We can help in that form to actually archive the data in a secure environment and then reduce the sprawl and risk of that data inside of your organization. Another very critical aspect is monitoring file access because we know we have identified sensitive data pockets with our discovery by now. We know the financial risk if something happens to that data. Now, using our smart cipher technology, you can actually go not only encrypt the file so that you can guarantee no unauthorized access is possible, but you can also go in and start looking at how people are using this particular data. And you can feed this into your SIEM so you can actually get near real-time activities of unstructured file operations. You can see who actually opened the file, copied the file, where it's being copied to, what other activities, cut and paste operations from those files have been taking place. This is a big extension to your EDR or endpoint detection and response capabilities because you get this information in near real time. You can also use Smart Cipher to actually block particular operations. Let's say you want to make sure that particular files only get printed on the legal printer in building X, third floor, 25th printer on the right. You could actually do this with Smart Cipher as well. So you can actually limit the exposure by people operating on those files. And you can track this even when the file is copied because the destination will have the same tagging automatically attached to it. There is no need to rerun the discovery process on that particular storage location because you already know that is being done. What this might actually be looking like is something like you see here. This is an example of an event. Somebody took a file and made a copy of the file or deleted a file from the file system. And the detailed information that your scene can use to correlate all the information in that space. But it's not only the unstructured side. It is also very important to do the right thing on the structured side. What many of people have been using in the past is dynamic data masking to restrict access to the data. And dynamic data masking is a good tool if you don't know much about the data. But when you have the better understanding of your data, you can actually reverse the dynamic data masking because what you're doing is privileged users get the live data, but who is privileged? Who is not privileged? If you flip the coin around and actually say, I'm protecting my data by default and only give live data to the privileged users that should have the data, you actually get far more out of it because now you're not monitoring the people that have protected access. You can monitor people with live data access. And again, you actually get near real-time insight into your sensitive data access. Now you can actually monitor and correlate events with application workloads. So why do we have this spike in application X? Is it because somebody is playing around with the data? Or does the business flow? Oh, we had 10 times as many orders today as we usually had, or transactions in that environment that justify 10 times more encryption decryption events. You can see that and correlate and act upon it. And if that correlation works, there is no more transactions, but an increase in decryption in that particular application, you can investigate immediately and identify what is the real reason behind this phenomenon. That is really an early detection of exposure of sensitive data where it should not have happened. So you have far more tools in the toolbox this way to actually identify live data access at any time. With that information that you have at this point, you can actually take a look at not only who is doing that, where it is happening, how it is being happened, what particular areas are exposed in this equation. So you get a whole big tool set in this case to monitor live access, unstructured or unstructured data in your environment. Just by taking the initial step of discovering and understanding what you have and how you better protect yourself on these data elements. Let's have a quick look at how we can also solve the and test data management in a secure and compliant way for you.
Hello, and welcome to the CyberRes presentation of Secure and Compliant Test Data Management, a use case of Structured Data Manager. My name is Brian Majora, and I'm part of the pre-sales organization for Voltage in North America. Before we get into a demonstration of secure data management, providing test data management, let's talk a little bit about exactly what test data management is and what we're going to be showing you. So in my system, I have a production database. Now, that production database may contain sensitive data in it that you would not want developers or testers or QA or training non-production users to see. But essentially what we're going to provide is we're going to leverage that data in the production database, create a subset extraction, so a smaller instance of that data set, less records, and anonymize that information and provide it to developers and testers. The key is that developers and testers will get a full referentially intact set of data. It'll be a smaller set of data than was in production. And the data will look and feel like real data. It will have real names, real addresses, real social things that would look like real social security numbers, but they will not be the real information from production. It will be anonymized. In terms of the actual demonstration agenda, these are the steps that I'm going to go through. The first thing that we're going to do in the demonstration is I'm going to show you the production database that I have. We're going to attach to that using the Web Console Data Discovery module, and we're going to scan for sensitive data. Once we understand which columns contain which types of sensitive data, we're going to generate dictionaries from the Data Discovery console. And what a dictionary is it's a random shuffled sample of data from those sensitive columns within the production database. Once we've generated the dictionaries, we're going to switch out of the Web Console and move over to Structured Data Manager Designer. We're going to model the production database, enabling us to create a referentially intact subset of the data from production. The next step we're going to do in Designer is select required masking routines that we will use to shuffle or mask or anonymize specifically the data in the columns that contain sensitive information. Once our design is complete, we'll deploy that design back to our Web Console, where it can be then where that extract can then be executed against the production database, resulting in a subset of safe and fake data that still looks real, confirming the anonymized nature of the data. And then we'll finally look at how we can upload that extract to a test or development instance using our test data management extension. So let's get started. Let's start with our production database. What you see here is I have a database with a series of tables, contract, billing, order entry systems. This is my real production data. I have testers that need an anonymized subset of this data so that they can perform their testing. So let's start in our Web Console, where we'll bring up our discovery solution that'll allow us to scan this database and determine which columns contain sensitive data that would require masking. On the console here, I've pointed my discovery module at that particular database, and I've done a scan, and you can see from the result readout here that I have 180 columns that are determined safe and 33 columns in the red here that contain some type of sensitive data. Clicking on this database takes me inside the database where I can start to see the risk and the number of sensitive fields per table. Down further into the table list, I can see which tables contain the most amount of risk. So you can see I've got a customer table here with 15 columns that contain some type of sensitive information and 3 columns that contain something that we think looks relatively safe. Clicking on the customer table takes us into the column view. Now I can start to see, we're looking at each column and the type of sensitivity that we found within each column. We can see we found data that looks like email addresses, data that looks like postal code, gender, but we also found some very sensitive things that look like social security numbers, things that look like credit card numbers. So these are the columns that I'm going to need to anonymize to make safe in my subset that I provide to testers. Once we've performed a discovery scan and we understand what type of sensitive data lies within which columns, then we'll create our dictionaries that we're going to use. So clicking on remediation, generate masking, we'll specifically create a dictionary file for each column that contains some type of sensitive information. We'll use those later when we go to mask our extract, our subset extract. Again, we'll randomly sample from our dictionary now and substitute the values of the records that we pull out of production. With that in place, we switch over to our design time interface. This is Structured Data Manager Designer. From here, we model the production database and use parameters to determine how we are going to sample data from that database. So in here, I've added a little bit of PostgreSQL in here to say that we're going to be getting a random sample and we want to limit it to some number of records. So the tester or the developer who's performing the extract, at the time of extract, they can decide here how many records they would like to have in their subset. All of these are options. This is the option that I've chosen to illustrate that capability. Once it's modeled and we know how we're going to subset, then we need to start deciding how we're going to mask the specific sensitive fields. So what I've done is I've created a cartridge over here on the left for my billing tables. And I've said, okay, from the discovery, we determined we had credit card information, email information, first name, last name, social security number. In here, I actually decide, okay, for the data that comes out of each record, take the email address and randomly substitute it with a unique value from our email dictionary. Randomly get a first name value from our dictionaries. Randomly get a last name, a phone number. For credit card and social security number, I'm actually going to use a voltage secure data format preserving encrypted value. Still going to look like a credit card and still going to look like a social security number. So this illustrates our direct integration with voltage secure data to not just scramble and randomize certain fields, but actually to perform encryption and protect the data through format preserving encryption. Once I have this set, I will deploy this cartridge back to my web console for execution. In the web console, I can select our test data management extension. So let me change over to my Postgres database project. See here, I have several data generation cases. One for billing, invoice, order, contracts. Well, just before in Designer, I created my billing extract to determine how it was going to subset and how things were going to get masked. Simply by clicking on this green arrow here to run, that's going to run that cartridge, which will attach to production, extract a subset, mask the data in those columns, and upload that data to my test database instance. Let's have a look at the databases before we actually run that though. As I mentioned before, this is my production data. This is where data is going to be coming from. I have my customer table and my customer production data. Now I've created a non-production database, which will be my target for my subset of an anonymized data. In here, I have the same database name, the same schema, but I do not have any tables or any data in my QA database yet. So going back to our test data management interface, I'm going to run my create billings test case. And the first thing that it's going to do is ask me how many records I would like to extract. So I could have hundreds of thousands or millions of records in my header table, but this gives me my ability to define how many records I would like to show up in my test or my development instance. So let's go with 100 to start. I'm going to choose what that instance name is. And remember, we were going to put it into our quality assurance or our QA database as our target. And then I simply hit run. So SDM is currently connecting to the production database, performing that extraction, masking the data in that extraction, and uploading that data to my QA Postgres instance. Looks like it's finished completed. Let's go back and look at the actual data now. So as you recall before, this was our production data. Jack Jones was customer number 1. Paul Sanchez is customer number 2. All of this data is real data that a QA or development tester should not see. Looking at our Postgres database where we push things to into our QA instance, now you can see we have new tables in there with new data. Clicking on my QA database, sorting by customer ID, you can see I've got a customer ID of number 14, which is now Clev Fields. Customer 14, now there is no Clev Fields in the real world. If I come back to my production database and look at number 14, that used to be Vivian Moore. Scrambled the credit card number. We've scrambled the social security number. Going back to that QA database, this person, Clev Fields, this credit card number has been encrypted with voltage. This social security number has been encrypted with voltage. This email address has been swapped out and anonymized with another user. So all of this data looks relatively real, but isn't real, and nobody's sensitive or private information can be compromised by non-production users. So that was a quick look at the process that we went through. Scan that data for sensitive information, generate our dictionaries and create our subsetting data model, select how we're going to mask and how we're going to anonymize and protect that data, and actually execute and view the results of that. Overall, what was accomplished is we took production data, made a small subset of it, and anonymized it and provided it to non-production use cases. It looks like real data, it feels like real data, but it is not real data. It is a safe instance of data for non-production users. If you would like more information on secure, compliant test data management, you can reach out to me at brianmajora@microfocus.com or contact your local CyberRes Voltage security representative. Thanks very much.
And again, every data protection and privacy plan begins with the data discovery. It's a continuous process to reduce your risk and increase your cyber resilience. Number one, we've shown you how to know your data. Do the data discovery using our file analysis suite and the structured data manager. With that, you can better understand where you're overexposed and minimize your data footprint where the data does not have any real business value at this point in time, which then reduces your financial risk as an organization overall in case something happens. And when you take all these learnings and actually apply the protection to the sensitive data, whether it's smart cipher or secure data for structured and unstructured, then you can actually increase your insight into activities on sensitive data in your organization all the time. With that, I would like to thank you all for joining this session today as part of the cyber side. And I would like you all to get social with us, whether it's on Twitter, LinkedIn, or on the Micro Focus CyberRes community. Thank you.